Thank you very much. Thank you for having me here. Welcome to ColdFront. The truth is, my real name is really long, so I usually put just Eva Ferreira. You can call me Eva, or Efa. It's fine. I'm a UI developer at Aerolab, and I'm part of the CSS Convergentina team. We're coming back next year, so if you're interested, just keep an eye on us. And also one of those persons that likes design, but is a terrible designer. And hopefully I'm not alone in the feeling. And I'm here to talk to you about color. And the truth is that when I was a teenager, I went to a high school where they taught me some programming, but they taught me Turbo Pascal, and it was awful, especially for a 14 years old. So it's like, how can we make teenagers hate programming? Okay, let's teach them Turbo Pascal. But luckily, I began doing some CSS and HTML at the same time, and I found out like I can code stuff. And the one realization that really blew my mind was that color is code back when I was like a teenager, and that since color is code, you can actually do whatever you want with it. You can do math if you want with color, and that's really interesting because we usually don't take color as code or as characters. So that's really what this talk was going to be about the color in CSS, the past, the present, and the future, and how it impacts our everyday lives. And it's more specifically about color schemes, which is the way we name color in CSS or in different languages. So, for example, if we want to use a black color, we can name it in RGB in decimal or in hexadecimal. When we talk about color schemes, what we are looking for is that it is intuitive. We want not to remember colors by heart, but to actually we want it to be easy to use them. We want to have variety, not only 10 colors, and also we want them to be easy to modify. For example, if we chose a kind of orange, we want to easily modify that orange and add a little bit of lightness or make it darker without having to go to a graphic user interface like Photoshop or open a color picker. We want it to be easy as to just change the code and understand what is going on. So if we do a recap from CSS1 in 1996, there were these three options available. We could use color with names, there were 16 available, RGB in hexadecimal or decimal. Back then there was no alpha in the RGB decimal, but it was cool. So with color with names, back then there were only 16 available. They came from the Windows VGA palette, and there were these. And then you could also use RGB in decimal or in hexadecimal. And then in CSS2, they added orange. And that was it. It was great. It's like, hey, we now got orange. Then in CSS3, they deleted orange. But, and the truth is that CSS3 began working in 2001, because we might think CSS3 is like 2011 or something like that, but it actually began way before that. So they killed orange, like they regret it, and then they put it back again, but not as this part of the 16 VGA palette, but as part of the X11 colors, plus 146 another. What is the X11 colors? It's a TXT file we have on most of our computers, and it defines the colors we can use on our terminals. It has the RGB value of each color and a name. This has been around for like the 80s, and they implemented it in CSS, in CSS3. So some of it was great. We could actually use orange, brown, chocolate, beige, violet, and gray, and gray. So if you were British, you were really happy about it. And some of it was really nonsense, really chocolate. I mean, what kind of chocolate? It's not easy to know if it's like milk chocolate, bitter chocolate, only how much cacao. I don't know. There were two colors that are exactly the same. Cyan and aqua, they are the same. Gray is darker than gray. We are never getting over this. Never. Guess what is not scary? Who is Sandy Brown? Because Sandy Brown is color. Peru is a country, and it doesn't have any brown in the flag. So it's like, okay, tan. Tan is a color. So there are a lot of these that actually have funny names. Some may be a little racist. But the main problem is not that. The main problem is the lack of consistency. And that is actually what makes this a really bad color scheme. Because it wasn't really made for CSS. It existed years before. So the lack of consistency turns out to be a really big trouble when we actually have to remember these names by heart and cannot really try to use them without knowing them all. For example, I hate it that there is an sky blue and there's no hell red. So it's really bad. I would love to have hell red. But really, what is the main problem with this? For example, Nevada white is not white, but it's called white. Maroon looks reddish. There is light blue, blue, medium blue, and dark blue, but only red and dark red. And that is the real problem with this color system. You cannot use it if you don't remember each color individually. So they are pretty much arbitrary. And this year, this news came out, and it's really interesting. It's an artificial intelligence system invented a bunch of new paint colors. And they are like, whatever. And it's not as, these are really, really bad. Our X11 colors are not that bad. But really, there is not much difference between this one and the other ones. So if they are so bad, why are we still using it? Why is it still there so many years after that? Well, I found a quote by an stranger on the internet that pretty much sums it up. It says, they are not efficient or super intuitive, but there is something downright charming about using these great names. And I think I must agree, they are not really useful at all. But it's fun to write a sky blue or Peru, and that Peru is a country, and it's also a color. So that's what they have. If you want to take more look into this TXT file, you should watch this talk by Alex Sexton. He explains like the history of it, and it's really interesting. So that's color with names. They are not specific. If I want a really, really particular shade of blue, I probably won't get it. There are only 148 available. I'm counting Rebecca purple here, even though it isn't part of the X11 colors. And they are impossible to modify. If I have red, and I want it to be a little darker, then I'm in trouble, because there is no medium red, and dark red might not be the one I want. But they are fun to use. So what else is there? There's hexadecimal, which goes from 0 to 9 and 8 to F. You can use them with 3 digits and 6. And also, you can now use hexadecimal with alpha. 4 digits, which beware, because it might be really confusing. If you consider 0009, you might think that you are talking about 90% opacity, but it's actually 50, because the opacity is in hexadecimal as well. And then there's 4 digits. And currently, this works in Firefox and Safari, and it's going to be implemented in Chrome and Opera soon. And eventually, I guess it will reach Edge. They also have funny names. You can build really interesting words with it. And now that you can have 4 and 8 values, you have even more possibilities, like coffee or coffefe. I bet that's what he meant. Cat, badass, and fiesta. Who knows what fiesta means? Yeah, it's early, but we know it. So in case you don't know, fiesta means party in Spanish. How does fiesta look like? Think about it for a while. Does it look greenish, yellowish, or reddish? Probably the only thing we can tell is that it must be like a light color, because most of these values are towards the F, but there's not much more we can tell about it. It looks like this. It's kind of yellowish and greenish at the same time. So it's really hard to use hexadecimal. It can be really specific, because if you use 3 values, you have around 4,000 possibilities. If you use 6 values, you have almost 17 million possibilities. So there is a lot to choose from. but they are hard to remember, they are hard to modify. If you finally found your favorite orange, then to turn it a little darker might be hell, and you might end up having to open a color picker, and that's not the idea. Then there's decimal RGB, which is pretty much the same. It's a specific, hard to remember, hard to modify, but at least the alpha works everywhere today. Then there's HSL, which probably changed everything we know about color when it was created, because it's actually one of the most intuitive there is. HSL is from hue, saturation, and lightness. Hue is what we commonly know as color. It looks like this. It's a icon where in the out circle you can find the hue. The hue is a circle, so you will find that it is degrees from 0 to 360. The saturation goes in the middle. It says, okay, how strong will this color be, or how gray? And then the lightness is in the y-axis. It will tell if it is darker or lighter. So since it's a circle, you can use degrees. And it works like this. 45 degrees is kind of this yellow. And if you put 0 and 360, they are exactly the same. They are this red. So you can go from one color to the other without worrying too much. And you can do this without modifying the saturation and the lightness. So it's really great and really easy to use. If you put the saturation down, you have this gray color. And if you put it up, you have a really strong green. And the same with the lightness. So if it is in degrees, we can do this kind of thing and move the hue without moving saturation and lightness. For example, if we want this green to be lighter when we hover over it, it's really easy to do. In comparison with hexadecimal, you just put the lightness up. And then you get this wonderful effect without doing too much, without having to go to a color picker to guess, okay, what is the next value? And HSL also gave way to another thing that is filter hue rotate. And filter hue rotate is a way of modifying the hue a certain quantity of degrees. And you can do this really useless thing. For example, you can begin in yellow, any kind of color scheme, you can use hexadecimal, and then turn it 360 degrees around. So it will go like this. It is completely useless, but it's interesting that we can do this, and that it actually comes from this idea of having a hue available. And if you want more useless stuff, you can apply it to gradients. It's like, wow. I'm never going to use it in my life, but it's so good. So it's great. HSL is specific. You can have a really, really large different colors. It's kind of intuitive, much more than the others. The alpha works everywhere. It is hard to remember because there are a lot of values. But it's great. It's easy to modify, and it's ideal for transitions and animations. So that's all for CSS Color Level 3. Let's go to the future. First of all, in CSS Color Level 4, which is right now a draft, we have optional commas. So now we have changed the way we write RGB and HSL. We no longer need to write the commas. It's not a big change, but it's OK. And you can differentiate the alpha in a really easy way. You just put in a slash and write it. So that's great. Can we use it? Yes, kind of. The truth is, there is no data in caniuse.com about this because it's such a tiny change that you actually have to try where it works and where it doesn't. Right now, it is working in Firefox. So as you see here, we got this is the alpha. If we don't want any alpha, you just delete it, and it works. It's great. But it only works in Firefox. And you can do whatever you want. So only Firefox, but it's OK. It's fine. It will eventually reach, I guess, other browsers. Then in CSS Color Level 4, we also got all these new color schemes. And that felt like a lot. I don't know about you, but it was like, OK, there are too many. Why are there so many? And at first, it was like, why not? I mean, let's just have more and more and more forever. But the truth is that there is a reason. The current color schemes we have don't really fulfill our needs. For example, what if we want to do, or to have in this case, more intuitive systems? Because HSL is really good, but it's not really the best we can do. We want device-independent colors. What if we want to do theming in an easy way, or customization? And what if we do theming and customization and we want to ensure contrast? Then we also need a color schemes that can allow us to be certain that there will be enough contrast if the user is going to pick a color. So regarding device-independent colors, there's an amazing talk about that from last year's CSS Conf Asia. So I'm not really going to go into that. It's by Chris Liley, who is one of the authors of the CSS Level 4. So it's an amazing talk. You should really go and watch it. But I'm going to go into the others. And that means we are going to take a look at HWB, gray, and color mode. First of all, HWB is hue, whiteness, and blackness. And it tries to be a more intuitive system. It works something like this. You have the hue, which is degrees, the whiteness, how much white you want to add, and the darkness. It's supposed to be more intuitive because the user might be more familiar to just pick a color and mix a little bit of white and a little bit of black. Right now, if you add more black and white and suddenly you stamp 100%, you end up with gray, because what you are doing is taking away all the hue and replacing it with black and white. So, for example, if you have 0 degrees, it's a really strong red, and you can add a little bit of black, and you get a darker shade of that gray. And when you go over 100%, you get into the gray world in here. This currently works with PostCSS. There's a plugin called CSS Next that can make this work, and it's great. Also, there's the gray function. The gray function is not gray with an E, but it works anyway. And you can have something like this. The alpha is optional, and then you can use percentages or not. Again, this works with PostCSS, CSS Next plugin, the same plugin as before, and it's great. I don't know if you've ever been into something like this, with you have like 20 variables of gray. Yeah, we all been there. Well, the sad truth is this doesn't really solve with gray. Gray, you don't really solve it with a new CSS color scheme. The only way to solve this is actually talk to your team and create a wonderful style guide. Because really the main problem is that we are not defining the colors we are using, and then we suddenly have like 20 different colors in a website, and it's madness. So a style guide. And don't be afraid also to talk to each other, like designers with developers and developers with designers. We can make better websites if we actually talk to each other and create a style guide. If you ever work on a style guide, it will make you a really better developer, and it will make also better designers. So really do style guides. Then there's color mode. And beware with color mode, because everything I will say today will probably change over the next few months. So color mode is a modification to a base color, and it is way more intuitive because you choose the color. So you can choose the color in any notation you want, in hexadecimal if you want, or in decimal, or in HSL, and modify it with these things. You can apply hue, saturation, lightness, or thin shade, blend, and contrast. It has a lot of modifications. And it is ideal to work it with custom properties. So for example, if we have a really strong red, and we apply saturation and whiteness, we end up with this background color. We can also modify the tint. Tint is a way to make it a little lighter. And then we can also have the contrast modification, which finds either black or white, depending on the percentage we write. If we write 30% in a purple, we get this background color, which allows us to use a black text, and it will read OK. And if we want to ensure 100% contrast, we can turn it into 100%, and it will turn the color into black, white, or black. So it's great. Can we use this? No. Not even with PostCSS. The truth is, this plugin, CSS Next, is great for the other ones because it works amazing. But for this particular one, for color mode, it is outdated. It has not color mode, but color, which is like something from a year ago. Then they changed it to color mode. So really now it's out of date, so I wouldn't use it because it won't be future-proof. And the idea of using PostCSS is actually to have future-proof code, and you won't really get it with this. But if you want, you really can go and use PostCSS with this. I wouldn't recommend it, but you can't. So what about this? What if we want to do theming, customization, and accessibility? Well, we can use the current tools we have. It might be a little bit far-fetched, but it does work. So for theming and customization, we can use HSL, filters, and custom properties. And for accessibility, we need a little JavaScript. Just a little recap. Theming is when the company or the designers or the developers choose to do different kinds of website with different colors, mostly changing only the UI. For example, the BBC. It is a control environment because it's the company that chooses it. And customization is an uncontrolled environment. It's when the user picks a certain color in the UI. For example, in Twitter, we can pick a different color for our text color. So, theming, how can we do it with CSS right now without having to go to this CSS Color Level 4? I made this pen, which is exactly this, almost the same as an Anna Tudor's code pen, where you can change the hue with an input type range from 0 to 360. And the idea is that you can actually modify everything by just changing one value instead of changing all your code. So in this case, if you want to make a red version or a yellow version, you write a hue, and you use custom properties. So everything will go around the hue you choose. Then you create a couple of another custom properties, one that's kind of natural with an 80% saturation and 40 lightness, and then you create a darker version and a lighter one. With these other two versions, you can ensure that the things you do with this here will be accessible, because what you will be doing is to apply, for example, to the links, white text color and the darker version of the hue. So we can assure that, okay, this will look good, this will be accessible. If we want to color the images, in this case I use a pseudo element, but you can also use filters. The problem with filters is that it might not work in Firefox, because Firefox has a bug with calc inside another functions. It has already been reported. I guess it will eventually be fixed, but this doesn't work. So right now, if you want to reach every browser, you probably will end up doing a pseudo element. If you want to get the inverted color of the one you chose, like a red gets the other one, you can sum 180. Again, this is the same problem. It won't work in Firefox, but you can get the inverted color if you wanted to. You don't need to worry if you go over 360, because it will just turn around and pick the right color anyway. So HSL plus custom properties was great for theming. You can ensure an AIA contrast, because again, it's a control environment. It doesn't have enough customization, but again, it's a control environment. So you can only pick the hue. You cannot pick the lightness or the saturation, only the hue. And there's a bug present in Firefox that you might or might not encounter. So what if it isn't just a hue? What if we want to modify more things? What if the brightness of the color is unknown? How can we ensure that it will be accessible? Well, that's customization. That's letting the user choose a color and applying it. For example, again, Twitter. In Twitter, if you choose a color that is very, very light, like this, eventually it will turn into blue. Now, so if it turns into blue, to ensure that it will be accessible, to ensure that you won't use white text over white background. And we want to do something like this. We want to ensure, like, okay, if you are choosing a color that is not really good for white or black, then I change it. So, to do accessibility with background color and text color, is CSS enough? I try, and no, CSS is not enough. First time I tried with mixed blend mode of exclusion, so you can actually apply a white text color and it will mix with the background the user picks. For example, I pick a color and it gets this one, and it looks like it is working. The bad thing is that actually you don't know what color, text color you will get. So it's not really nice. You might get this kind of blue color and you don't want that. And also it's not 100% working, because if I put a really strong purple, I end up with this. And this is not accessible at all. So really we need JavaScript to do this. And what we are going to do is to define one of those two things, either the background color or the text color, because we cannot let the user define everything. If we do that, we cannot ensure accessibility. So we will be working with background color picked by the user, and we will apply dark text or white text with different classes. And to do this, we need to find the brightness of the value. So to search the brightness of the value, we need to differentiate the red, the green, and the blue, and do that math. You might notice that the green has a really high value. That's because the green has much more brightness in it than another one like the blue. So once you do the math, you divide it by 1,000 and you end up with a number. That number will tell you how bright the color it is. And for example, this green gives us 151. That means the color is really bright. The point of change is usually between 120 and 130. So we can say the color is bright and we apply dark text color, like actually Reveal.js is doing here. So it's pretty much like this. You put the brightness. If the brightness is above 120 something, then you apply dark text color because it has a really bright background. And otherwise, you do the other way. So we can check it here. If you apply white, it's bad. If you apply black, it works. And you can try it again in multiple different colors, and it seems to work. If I pick a really light shade, I will get black text. If I pick a really dark one, I will get white text. The problem is when I end up picking colors in the middle, like this. It is okay. It gets you if you tried an AA contrast, which is acceptable for large text, but it's not that good. And sometimes the system really fails. For example, we take this other green, and we do the math, and we end up with 124. That means the color is dark. So we apply white text. But actually, if we try it in constant ratio, this tool valia below, we will find that white turns into an AA contrast, which again, it is acceptable for large text. But if we put black, it gives an even better contrast. So the truth is that it's not only about color brightness, it's also about color difference, and we are not taking that into account. To take that into account, you have to do a lot more JavaScript. But if you wanted to, if you really want to ensure accessibility and you don't really mind if the color the user picks is not exactly the same, then you can also do something else that is much easier. If you are between 115 and 135 of brightness, that's the problematic point, the problematic range, you can actually turn the RGB into HSL and put the lightness down and apply a white text color. So the user will get the shade he chose a little darker, and you can ensure accessibility. Or you can do the other way around. You can apply a lighter and HSL, and then apply black color. So it looks something like this. If the brightness is between 115 and 135, you go and turn this color into HSL and modify the lightness, and apply a dark text color. this function is really long that turns into from RGB to HSL. So I didn't put it here, but you can check it out later in the slides. What it does is it takes the lightness and it puts -20. So now the color is darker, and you can apply white text color without worrying about it. For example, it should be working everything up to here, plus this new thing. So if we pick again a really light color, we get the exact same color with black text. If we pick a really dark text color, we get the same color with dark white text. And if we pick something in the middle, like this, we will get a little darker version of the color he chose. But we will apply white text and ensure accessibility. So we take the lightness from 51 to 31 of this original color the user picked. And it will work with any shade. Let's see. There. So it's almost the same. I mean, you have to know that the user won't have exactly the color he picked, but it's pretty much OK, and you can really ensure an AAA contrast. So if you want to go and look for color converters, you can go to GitHub by M. Jackson. There is one really cool color converters in JavaScript from RGB to HSL and the other way around. They are really useful to do this. Also, there are some codes available in JavaScript in the W3C CSS Color 4 spec, so you can find them there too. And then later you can also check out this demo and find the converter. What if everything is customizable? What if actually we let the user pick not only background color, but also the text color? Why would you do that? Just don't do it, because you won't be able to ensure accessibility, and the user might have a really bad eye and put really awful colors. So really, don't do that. Last 3 remarks. First, media queries. There is a couple of operative system options that are suddenly and slowly turning into media queries, and it's really interesting, and I wanted to really mention this. For example, the reduce motion one. It began as an iOS and macOS problem, and then it slowly turned into an option you can toggle in your phone or in your Mac. And now you have, for example, a media query that they are working on reduce motion. So you can actually do a media query on reduce motion and pick whether you want to show animations or not. Also, in Android, you can find different options like color inversion or color correction. So if you have a kind of color blindness, you can actually modify the way your phone shows colors. And again, you can modify the font size or even activate a high contrast option in the Android phone. So all those tiny things are slowly turning into media queries. Media queries level 5. So really, we are, like right now, we are working towards level 4. This is level 5, so it's really like future, like patient. And we will have inverted colors as a media query. We can actually check if the user has picked to have inverted colors and do something about it. For example, uninvert images, because for the user it might be awful to have an inverted image, but really useful to have an inverted color. In text. Reduce motion, again, is another media query. They are working on it, and right now it works in Safari nightly, if I'm not mistaken. And reduce transparency, which is a really good idea. You can actually, as a user, pick if you want to reduce the transparency on the websites you are visiting. That's ideal for my mom. My mom doesn't have a really good eyesight, and sometimes transparency are really good for design. They look really amazing. They make like these amazing websites. But for people that have a blurry eyesight, they are really hard to understand. So actually, to just toggle it on and off is amazing for this kind of people. Number 2, do not trust color. I mean, this whole talk is about color, but do not trust color. For example, if you are trying to submit a form and you say, OK, if it is green, it means that the value is OK. If it is red, the value is wrong. The truth is the user is colorblind. He won't see that. He will only see the two values colored the same. So try to always add another way, and not only to rely on color. You can add icons or a text that says, OK, this value is wrong. And last, get feedback. Because the W3C draft are right now on GitHub, it has never been more easy to get feedback to the W3C on future specs. So if you have something to say about color mode or HWB or even media queries level 5, you can go to GitHub and get feedback in there. Open a new issue and just talk about it. So we can build these CSS new features together. So that's all. Thank you very much.